And thanks for tuning in to section 8.2 of our book on arithmetic sequences. Now, in the first section, we just talked about sequences, and it didn't matter what kind of sequence it was as long as it was a pattern. This particular thing is going to deal with a specific type called arithmetic. Arithmetic is when you add or subtract the same number every time to your sequence. So, for example, they're going to give you something that will automatically add or subtract every time by the same number in order to get that. It has a formula for you. It's defined, and here's the nth term, or the first one. A1 is the first term, plus n minus 1 times whatever the d is. This means first term, so that's your starting point, and this means common difference. Now, for this particular thing, I know that a lot of you guys know what it means by difference. Difference means to subtract, but what they're referring to in this particular case is what number do I add or subtract every time in order to get that answer. So in this first example, what they're going to do is they're going to give you a sequence and ask you to figure out what the nth term is. So if they say something like 9, 4, negative 1, negative 6, negative 11, how are they going? Well, first of all, if I wanted to come up with the nth term, my first term was 9, and minus 1 is always going to be there. Now, what are they doing? How are they going from here to here? Well, they are subtracting 5 in order to get that answer. Okay? Subtracting 5. Subtracting 5, subtracting 5. So the common difference is minus 5. Now, me personally, I always put the d in the back like that, but you could always put it to the front. That's not an option, or not a big, huge thing. Just depends on how your person would, or how your professor would like it. Another thing that I've also known, or have some colleagues know, is that they distribute this out and have negative 5 and plus 5, and they simplify that up to be 14 minus 5n, which is another acceptable way. This is acceptable, and this is acceptable depending on who your professor is in order to what they officially want. If they want it multiplied out to simplify it, or if they'd rather just leaving it. Me personally, I think just leaving it's fine, because I'm not asking you for for a specific, how do you multiply or how do you FOIL. I'm looking for what's the sequence. Okay, how is the pattern working? That's my take on it. So, but it would ultimately be up to whatever your instructor would want you to do. So a lot of times, what they'll ask you to do is they'll ask you to find the common difference, find the first 6 terms, the nth term, and then like the 100th term. Okay, so for instance, if I look at this one right here, I'm giving you 4 terms, and the only reason why I'm giving you 4 is just to establish a pattern. If I only give you 2, it doesn't really give it any credibility. But when I'm looking at this, I'm subtracting 6, 6, 6. If I do it 3 times, I'm pretty sure the pattern's pretty good. So one of the ways that I could do the first 6 terms is I could simply just subtract 6 every time in order to get the next one. So negative 11, negative 17, and so on. Or you could find the nth term, which is the equation. Again, we started with 13, and minus 1 doesn't change, and the common difference is negative 6. That's my nth term. So what I could have done is I could put 5 in this case and 6 in this case, and hammer it out and see what actually comes out, and should come out with a negative 11 and negative 17. But a lot of times they'll ask you to also find the 100th term, which means you're going to put 100 in there and see what you get. Okay, so if I take 13 and then 99 times negative 6, whatever that number happens to be, we got 13 minus 594, which would then equal negative 581. Okay, so just so that you are aware of it, There's many different ways of going about doing it. Sometimes they'll want the 10th term or the 100th term or whatever term they want you to do. But that's basically how it works as far as the formula goes. There isn't a hidden secret. There's not you trying to think about what or how to get to the next one. You use the formula and it will dictate it for you. So it's kind of nice in that respect. When it gets a little bit tricky is when they say the 11th term, or a sub 11, would be 52, and the 19th term, or a sub 19, equals 92. What's the equation? Well, if I'm looking at this, I don't specifically know the first term. I don't specifically know the common difference, but I can find it. And what I mean by that is if I put in 11, I'm going to get out 52, which means 52 is going in here. I don't know A1. 11's going in the N spot, and I don't know the D, which 11 minus 1 is 10. So I end up with 52 A1 plus 10D. And if I do the same thing over here, I have 92 equals A1 plus 19 minus 1 times D. And 19 minus 1 is 18. Now, what I end up having here is I end up having a system of equations just like we had in section 5.1. So, or I add or subtract one from the other. So if I subtract this over, I get 40 equals 8D. Divide by 8, and I get D equals 5. So now I have my common difference. Insert that back in. So 52 equals A1 plus 10 times 5. 10 times 5 is 50. Subtract 50 to both sides, and I get A1 is 2. So my final answer for the nth term would be A1 is 2 plus N minus 1 times 5. And then once I have that, I can put in whatever number they want. If they want the 1,000th term or 1,500th term or whatever, you just plug that number in and see what you get. So it's one of those things where you can use that system of equations in order to figure out the answer, much like you did in section 5.1. Then after that, you can also do the partial sums. The difference between the partial sums in the first section as compared to the second section is this one has a specific formula because we're dealing with arithmetic ones rather than just any old ones. The partial sums of an arithmetic sequence is defined by this equation. Okay, where n means the number of terms that you're summing. So if I asked you to sum the first 10, you'd put 10 in that spot. A1 means the first term. This means the nth term. So for instance, if I said find the sum of the first 10, you'd have to know the first term, the 10th term, and then of course the 10 is how many you're summing. So so for that particular concept, we have a nice formula for that where we could end up figuring out how many or what the answer actually ends up being. So for instance, if they told you that A1 was 3, the common difference was 5, and I want you to sum 20 terms, I could put that or figure out that out. Now, 20 is going to go in for n because that's how many we're going to sum. 3 is going to go in for the first term. Now, the only thing we don't know is we don't know what the 20th term is. But given this information right here, we could actually find that. So A1 was 3 plus n, which is 20, minus 1 times 5. So again, if I were to take, in this case, 3 plus 19 times 5, so you had 19 times 5, which is 95, plus 3 is 98. So 98 is going to go in that slot, divided by 2. So I take 98 plus 3, which is 101, divided by 2, and then I times it by 20, and I end up with the sum of the first 20 terms is 1,010. Now, one of the things that I've actually witnessed students do is if I give you that information and say, all right, find the 20th term or find the sum of the first 20 terms, they're sitting there going 3 plus 8 plus, and then they're just adding 5 every time so that you get the numbers 13 plus 18, and they're going all the way up to that they have 20 numbers. Well, the flaw with that is, what if you screw up one of the numbers? Then all of a sudden you're in a hurt, or you're getting the wrong answer just because you actually typed in the wrong part, okay, or you got the wrong answer for that. So be very careful. I would suggest using the formula. It's going to help you out quite a bit. But that is the formula. That's the easier formula. There is another formula out there that I think is a little more complicated for students. So this is the one I show. And just so that way, in case you're wondering, there is another option. But this one, I think, is the easiest one for students. So with that, that's section 2.